The TRIZ 40 Inventive Principles. Genrich Altshuller, creator of the theory of inventive problem-solving, better known by its Russian acronym TRIZ, analyzed thousands of patents and identified a group of 40 techniques that inventors used successfully to solve problems across different fields. To inspire new inventors in their problem-solving, I created this video illustrating one of these principles. Principle 34. Discarding and recovering. Make portions of an object that have fulfilled their functions go away, discard by dissolving, evaporating, etc., or modify these directly during operation. For example, dissolvable 3D print supports. Because it dissolves in water, Hydro support only needs to be soaked a few hours to easily work supports off by hand, or 12 to 24 hours to dissolve completely.
Hey everyone, I'm John from 3D Fuel. This is Hydro Support, 3D Fuel's water-soluble support material. Everyone's least favorite part of 3D printing is cleaning up support structures. Hydro Support dissolves away in water. Let it soak for a few hours to simply soften the supports and work them off by hand, or let it soak for 12 to 24 hours and the supports will dissolve away completely. Hydro Support is non-toxic and is safe to wash down your sink without killing any fish. You'll find that it has a high tensile strength and feels like PLA when it's finished printing. And for those of you already familiar with support materials, Hydro Support is a lot easier to print with than PVA. So what can you build with it? Print things with large overhangs, print things with complex inner geometries or deep cavities. Hydro Support is available now. Let us know what you print with it.
Conversely, restore consumable parts of an object directly in operation. For example, self-healing concrete. When the BioConcrete cracks, the mixed-in bacteria feeds on calcium lactate, joining the calcium with carbonate to form limestone, fixing the crack.
My name is Henk Jonkers. I've developed a new type of concrete. We call it BioConcrete. The problem we have with traditional concrete is that it cracks. And due to these cracks you get ingress of water and other aggressive chemicals, and that degrades the concrete structure. This is an example of traditional concrete, showing why it needs so much maintenance and repair. Here we see a crack, water has ingressed and the reinforcement starts to corrode. So what we do is we replace part of the aggregate material, so the stones, for hollow spheres which we fill with food and bacteria. We impregnate the aggregates and add that to the concrete mixture. Here we see an example of a piece of cracked concrete. You can see the crack and even a big hole. Here you can see that the bacteria have closed the crack and even the big hole completely filled with calcium carbonate. So nature has inspired us to produce this new type of material, a combination of biology and civil engineering, BioConcrete. It will save us a lot of money which we otherwise have to spend on maintenance and repair in the future.
Share this video and add your examples of this inventive principle in the comments below. Discarding and recovering. Make portions of an object that have fulfilled their functions go away, discard by dissolving, evaporating, etc., or modify these directly during operation. Conversely, restore consumable parts of an object directly in operation.